listen-only mode.
Right, thank you everybody for attending this afternoon, when New Zealand that is. I know there's a number of people from around the world dialing in today, so thank you very much for your attendance. I'm just wanting to do just a quick introduction. My name is Shane Beeman. I'm the sales manager here at A2K Technologies, and with me I have Brian Bowler, who's a business development manager here. Brian is primarily the contact point for the Struxoft WMF software, covering the Australian, New Zealand and Asia Pacific market. Firstly, we wanted to run the seminar today really to introduce what we would term the best of breed products in this space. We've obviously got the Struxoft WMF guys on the line. You'll see their presentation very shortly. We've got the Howick steel roll forming guys that have kindly participated in this as well. And we've also put together the Autodesk Revit solution that sort of pulls everything together. So just a brief thing on A2K Technologies. We're one of Autodesk's largest partners globally. We're certainly the largest in the Asia Pacific ANZ region. So as I mentioned, we cover the Asia Pacific region. So you know, our breadth and width is very, very large, and we focus in the CAD and IT space. So with that, I'd like to stop rambling on and pass the presentation over to Matt now. Thank you once again for your attendance. I know you'll have lots of questions during the presentation. I think Matt's happy to take those as we go. We'll answer those at the end. Thank you, and over to you, Matt.
Thank you very much, Shane. Hello, good people. My name is Matthew Londe, and I'm a technician here at Struxoft Solutions. Just so everybody knows that today we are recording this webinar, and everyone will receive an email after with a little bit of info, some contact information, along with a link to the recording of the webinar. Also, while I present today, we encourage you guys to jump on the chat portion of the GoTo, and you can start typing in some questions. I know a few have already started coming in, and I have Brandon here with me, and he's going to be fielding those questions. And if we have some time at the end of the presentation this afternoon, we will try to answer some live questions. So let me just run you guys through a quick presentation, kind of let you know what exactly is MWF. Well, metal wood framer, or MWF as it's commonly referred to, is an extension that runs directly in the Revit platform. So we recognize Revit elements as well as their openings and then frame around them in cold form steel or wood. Just so you know, we have the abilities. Today we're focusing on light gauge steel. And then we're automatically placing all of our framing elements, our details, our join configurations, our level of framing, our headers, and our king studs. So we'll definitely see all of this happening in the Revit environment. And this allows us to model, coordinate, and manufacture directly from our Revit environment. So we never leave Revit. We try to do everything right in the Revit environment. We tried to work smarter, a little simple. So this makes MWF a suitable program from everyone from wall contractors to GCs, panelizers, home builders, engineers, and estimators, because when we're looking at modeling, coordinating, and manufacturing, we can see here where all of these professions would fall under which category. So this allows us to work in multiple types of construction, such as larger commercial applications you can see here, right down to smaller. This was a preschool done by a client of ours in wood, to more complex shapes like you can see here, the ceiling. So this was performed by a company here in North America. Again, a little bit of wood construction here, to the larger, a little more complex, you could say, steel applications. Again, a lot of hospitals. We're going to talk about coordination with other trades and when we start looking at clash detection. So with that being said, here are a couple more projects, quite a few projects here. Clients have been nice enough to send over. Speaking of clients, here you can see a lot of our North American-based users. We do have a couple overseas already, spread out all over the world. So we need MWF to model directly in Revit. So we're going to see the more technical side of this presentation in a second. But MWF, whether it's walls, floors, ceilings, rafters, or trusses, they are all template-based softwares which the users create, such as stud spacing, like I mentioned before, header configurations, bracing options. We're going to take a look at how easy it is to actually place these things in our project in a minute. And from just to keep on with the level of detail in which we support, we really like to see clash detection performed in the Revit environment. So when we start working with other trades, we start linking in these models that we've received from our MEP guy, our structural engineer. He sends over all the structural work. We can link that into our live project, see the penetrations, create the openings around them, and then frame them based on what they were. So we're going to recognize these sizes and these Revit categories. So I can tell the software if I see something from 0 to 300 millimeters, frame it with one configuration, but if it's 301 to 900, frame it with a different kind of configuration. So there's a lot of intelligence within this, this tool built directly into MWF. And from here we need to extract all of this information. So we are working directly in the Revit environment. We are framing with Revit families, so we can use Revit schedules, Revit material takeoffs to extract this information. But what Revit can't perform for us is the level of automated details that you can see here on your screen right now. That shop drawing is automatically created. Every member is labeled, dimensioned. The bills of materials are created right there for me. And then we also have the option of sending this panel information directly to the Howick CNC machine. And I've been lucky enough to, I was at a client's facility who have a Howick machine. I've seen them working. They are very, very impressive. So we've broken up all of these modules into different suites here, the pro wall, the floors and trusses. We can combine them. The additional CNC modules, which we'll take a look at as well. So without any further ado, I'm going to jump into the Revit environment and take a look at this project. But we can pretend that I've received this model from my architect. It's come down the pipeline. I'm ready to start framing. So what I want to do is strip away any unneeded information. So here I've set up a bunch of 3D views. I've gotten rid of things like the trees and the site, the topograph. And I'm going to take a look at these walls that are clear here, right in the front. I'm going to select these 1, 2, 3 exterior walls. I can see, based off of their Revit properties, their exterior walls, they're 150 millimeters. I'm going to open the StruxSoft Solution tab, displaying the Pro Wall, Pro Floor, Pro Truss commands. I'm interested in the walls right now. So I simply need to hit Create, and then I need to select one of those templates I briefly mentioned before. So in these templates that you're seeing here, I have information related to stud spacing, bracing options, header configurations, things of that nature. So I simply need to set one of these templates as active, click the Create button, and I let MWF do the rest. It's reading the profile of these walls, it's recognizing those windows, it sees that door, and it knows, based off of the information that I've set into the software, it knows exactly how to frame these 3 walls completely different. Now we are based in North America. We have quite a few clients, very North American ways of building. I've been to Australia myself and I got to witness, construction techniques. So we understand that there is the need for that, so we've incorporated a lot of these header configurations that may be a little more familiar to you. Yes, thank you. So you'll notice here, header configurations, we refer to this as our symmetrical Y header versus our symmetrical V. If we head over here to this guy, you'll notice that framing this gable end wall, not a problem. Now, we all know that things can change in my project. Maybe this window moves over a little bit. Maybe I say, I actually don't want this window at all in my project. So whenever a change takes place within the Revit model, I simply need to select any element of that panel, hit regenerate, and MWF will recognize this change and update the framing around the new wall, you could say here. So it recognizes that that window is gone, it sees that I moved this window, and it updates my framing. So we can now see how quickly we can create these panels directly inside these walls. But what's really interesting is seeing the power and the post-processing commands that I can perform to these panels. So panel 102 right here, I can simply open up this panel's properties. I'll just move them over here so we can keep an eye on our panel. I can navigate myself over to the miscellaneous tab, and here I have a list of additional elements I can start adding to this panel, changes I can start making. So I'm interested in placing some K-braces inside this panel. Here I can specify the number of sections I'm interested in and the number of braces I'm interested in using in this panel. I'll start them somewhere from the middle, so from the third stud from the start. And I can start inverting these elements as well. Oops, so go like this. Just like that, we can create this. I can select my members. So if I have different size gauges or different members I'm interested in using for this bracing, you just say, I'm going to put them right in the middle too. Here. Just call this KB1. I can control additional cutbacks and clearances if I need. But I've created this pattern right in the middle of this panel for me here. I say OK, and these K-braces are quickly inserted into my panel for me. If I'm interested, let's take a look at this guy right in the front here. Perfect. Perhaps I need some, we'll use the MMV braces. So I need to add additional bracing through my members here. It's prompting me to select my members. So between this stud and this stud, I want to create some MMVs. Again, with some C150s. I can add tolerances in here. I can say put 25 millimeters. Between, I have control over the sections of these heights and minimum and maximum allowable angles. So let's just say OK here, and it's going to automatically calculate that for me and place them directly on those two members, just like that. Every single member is selectable. I can copy these elements. I can change them right here in within the Revit environment because they are simply Revit families. But we need to speed up the process in which we're doing this. We're framing these walls. So I'm going to jump to the inside of my office building here. And I notice that simply by looking at these walls, I have a couple of different thicknesses. I have a 140 here. I think this one's a big 202. Perfect. So I have multiple wall types within my project. That's expected. MWF has created what we call a template map. And in my template map, I simply map my Revit wall types to my MWF templates. So this is the first live connection we see between the two softwares. And now when I grab an array of walls, let's take a bunch of guys right here like this, I simply need to hit the quick create button and I let MWF do the rest. It's again reading the profile of those walls, it's seeing those doors and framing around them, again based on those template properties, just like that. So I quickly created, how many walls there? 5 different walls from 2 different wall types. Now I know you guys are seeing these 2 walls right here running down this hallway. Now, what if we're panelizing? We plan on sending these panels to the Howick machine later. So I have maximum allowable panel lengths. I need to restrict the lengths in which my panels are going to be created. So we select these walls. We're going to use the panel split command. I'm capable of adding or specifying minimum panel lengths, maximum lengths to be created, if one of these splits happened to land right on top of one of these doors, it would place it 100 millimeters to the left when looking from the inside. And I have a little gap here also. So I've used a 12 millimeter gap in between these panels. So I hit confirm. These markers are placed. Let's jump into a plan view. Actually, we can actually see these markers. There they are. So I have these little wall-hosted elements. They're 12 millimeter split gap markers. Now when I select these two hallways and I hit quick create again, I'm going to create multiple walls within these, multiple panels within these two walls. Give it a quick second here, and just like that, all of these interior panels are created. Now, if you guys are paying close enough attention, you'll notice that I have a couple of overlapping conditions here where my panels are meeting each other. Now, we haven't met anybody who frames like this, so I'm assuming you guys don't frame like this either. So what we need to do is place a join marker in my corner right here. So this is a library of previously defined corner configurations, which comes with the software. It's fully capable of working in metric and imperial. So here I have a condition. We see this one quite often, built up members for drywall connections or plasterboard or subfinishing, different ways we can call it. And you'll notice it will place my marker for me right here, this circle with an arrow through it, indicating that a join's been placed, and it rearranges my studs for me. So just like that quick create that we saw before, where I can create a bunch of panels at a single time, we also have what we call the auto join. So I can select an array of walls, whether they're 150s or 202s, whatever the case is. If they're multiple thicknesses, I can simply run the auto join, which recognizes all of these. I didn't set my auto join up for this one. Oh, I didn't change my wall types. Oh, it places all the joins quickly. What didn't I do? Let me just check, see why that didn't work real quick. What a treat. I get to see behind the scenes as to they should go. Change my wall types. There they go. So I forgot to set something up in my walls on the other side. User error. So you'll notice that I placed these three join conditions very quickly. And these walls are ready for framing. So let's stick with the idea of working with a lot of speed. You'll notice in Revit, sometimes we have identical instances we've modeled with model groups. MWF is capable of recognizing these model groups, placing the framing inside our walls again. However, these panels remain independent of the group. So I can now tell the software to look through the project for all identical instances. It sees the other three interview rooms here and places the framing right inside those walls. But as I said, each of these panels remains independent in case I needed to change something like the stud spacing or modify certain studs in specific instances. So we kind of get the idea of how quickly MWF is capable of recognizing these walls, placing our framing right inside them, modeling with braces, horizontal members very easily. We can jump back into 3D here, take a look at one of the more interesting commands. So you'll notice that I've loaded in this ductwork, as you can see here, and I can very easily see that it's penetrating through my walls. So simply by selecting these walls right here, and that ductwork, I'm ready to run the interference command. And I've set up this, what MWF refers to as a rule set. call it the clash detection rule set, that when it sees this smaller duct, I've set up that rule before that says anything from 0 to 300, use one type of condition. As I said before, from 300 to 900. For the larger penetration here, use a different option in framing condition. I also have the ability to merge openings. So if I have an opening, we can just say within 300 millimeters to the left or right of any other opening, merge it together and create one larger opening. We can see that happen over here in a second. So keep your eyes on where these elements are penetrating through these walls, because it happens when I click this little blue check mark. And just like that, all of these openings are automatically created for me. And when I place the framing inside this wall, I'll be able to see the difference just based off of the size of these penetrating ducts. So let's hide this wall real quick. We can zoom in and take a look. There we go. So I can see the opening. And in the smaller instances, I've told the software to stretch to the nearest on-center studs and just add this header and this sill, saving material. Whereas if I said if I have a much larger duct, I need to add an additional 2 members on the left and right, just like that. So just to remind you guys, if you have any questions on anything that I've been doing so far, feel free to type them into the chat portion of the GoTo, and Brandon's over there answering questions. So let's jump back to the other side of the building where I was before. Let's throw in a panel in here too. There we go. Now we can take a look at some of these panels. This guy looks pretty interesting right here. We can grab the top plate of him. We can take the label from this element right here. We'll just take these 2 instances. I'm ready to start extracting this information. I need to create the shop drawings of these 2 panels. With those 2 elements selected, I simply hit Wall Panel Drawing. I select the sheet size I'm interested in placing these panels on, and no 2 clients of ours create their drawings the same way. So there are quite the list of options and control and capabilities within the MWF software when it comes to things like dimensions and labels. So right now MWF is creating those views. It's placing all of these dimensions, and over here in my sheets, you'll notice interior 111 just showed up and interior 127. So just like that here, I can move this guy up a little bit. I can see that MWF has created this for me. It's labeled all of my studs. It's dimensioned my opening. It's dimensioned my horizontals. There I have a top view of my panel with an ordinate dimension style on there. I can still activate these viewports and delete anything I may not need. I can add additional members. So if at the last minute I need to copy a stud here or remove something, I can still perform all of those last minute operations. Let me swing over here to this bill of material. I can see this was a C75, the quantity, its length. So everything from rounding options to labeling techniques is controlled through the option files. Just like here, I can move these guys down a little bit. I can make this change once in my settings and not have to do it every time. So we try to generate these panels best we can first time out. And from here also, if I'm interested, if I need, I'm ready to just again select any member of my panel and simply generate the CNC. So I definitely want to use my Howick machine here. I have the option to add service holes at this point in my model. At this point in time, if I'm not interested in modeling them in every single panel, here I can say 300, 600, and 900, just for example. I'll just throw it right on my desktop, hit generate. There you go. And just like that, popped up on my other screen over here, right on my desktop, these 2 CSVs are generated. They're ready to be fed into the Howick machine. So again, that's a very, very quick overview of the MWF Pro wall. And we still have a little bit of time, just at half an hour right now. I want to jump into another view I have here. Just take a quick look at the floors. So here we see our Revit floor element. Like I said before, we've received our models from an architect. They aren't really maybe thinking about the panels that are going to go into these floors. So we've taken it upon ourselves to think of a way of creating multiple panels within a single Revit floor. So I hit create right here, and MWF just placed really quickly here, let's hide the floor, a series of nodes and model lines around my openings and around the boundary of my floor, just like that. I can jump into a plan view like this, and now I can start splitting this very, very large floor panel into smaller, more manageable, more realistic panels, simply by, whoops, I got a little lost there, zooming too fast. Sorry if anyone's getting motion sickness. I can place these two nodes, and now I can split this panel right in half. I have one single Revit floor element, and I have two MWF floor panels, I should say. So we can do that again real quick. We'll just put another node here and here. And we do have a clash detection option for the floors as well, so I can create openings around these columns that we see coming through. Just like that. We have 3 floors now. I'm going to jump back into the 3D view. I know my joists are going to be facing the wrong way, so I'm going to rotate this arrow and simply regenerate this panel. I'm going to see all of my floor joists get generated and show up in my model. And just like there they are. And just like the walls, these are all Revit elements, so they're all being quantified in my schedules for me. So that's a very quick look at the floors, just so you get an idea. Again, I can copy these members. There's all kinds of additional controls for adding things like bracing and strapping in these floor panels. But what a lot of people are interested in these days are trusses. So we are currently, we're always modifying. We're the manufacturer of the software. We're the developers. So we are continuously making changes to these modules, adding features, adding functionality. I'm interested in placing some common trusses in this roof right now. I've specified in my templates, the number of vertical members I'm interested in having, the gauge of these studs to build up my truss. So all I'm being prompted to is select my ridge line, select the supports where these trusses are sitting on. So let's use these two beams right here. Say finish. I'm going to sit on the far end of those beams. Use a How truss. And I'm just going to put a very large spacing here just so we can generate some quick trusses. Say OK. MWF is creating these profiles within the Revit environment, these trusses, and then placing them right here in my model, just like that. Thanks for the heads up. So we have some common trusses, just like that. If I'm ready to start doing some flat tops, again, put some hip trusses. Again, it's just prompting me to select the supports. So what are my trusses sitting on? My hip lines, that's you and you. So there's a lot of pointing and shooting, selecting elements. Say 300, minimum height, and spacing, say 900. It's good, I'm doing all the conversion from imperial to metric in my head, so I don't know if these numbers are going to look fantastic or these trusses are going to come out looking great. They may be a little bit close together. We'll find out in a second. So again, everything is template based. I specify the members I'm using, the number of verticals, diagonals, and as I mentioned before, we're continuously developing this software, so we are definitely adding controls capabilities into the trusses here. So there you go. You see I generated a couple of flat top trusses. And just like the walls that we had seen before, we have the options of creating drawings for the floors and for the trusses. We have the option of sending all of these modules, or so all of these features directly to one of the CNC modules like the Howick machine. So that is a very quick, very relatively brief overview of all of the MWF modules. So now, unless Brandon's taking care of all of them, I'm going to answer some questions. I'm getting the green light on that. All the questions have been answered online. And just to remind everybody that you will be receiving a video, a recording of this webinar. And if you guys have any other questions, please, you're more than welcome to contact A2K Technologies at their contact information seen here. And that concludes our webinar.